Be about continuations. The title is Continuations, the magic behind virtual threads. Basically, continuations is the magic that drives virtual threads to provide high scalability. And in the talk, I explain how that is done. So basically, let me explain that very briefly here. So virtual threads, as we know, have this expectation of providing high scalability, right? And virtual threads, when they, there are two aspects how they do that. One is that they are really lightweight, so they are really, their footprint is really tiny, so we can create huge numbers of them. That is one aspect. And there is other aspect where when a virtual thread is executing a blocking call, it doesn't block the CPU. So basically, virtual thread requires a platform thread to execute something, and then when it is executing a blocking call, when it is waiting for something, it gives up that platform thread. So platform thread is not waiting, and then CPU is not blocked. So that way, CPU is very highly efficiently utilized, and therefore it gives that high scalability benefit along with virtual threads. So that's how they provide that high scalability. But then in the talk, we go much more deeper and explain how that is done.
So so continuations, the next question,
Yeah.
right? So visual threads, that was like for many years the promise, and it's already here, and we see huge performance gains in different frameworks that utilize them, and just like, you turn one flag on and then it's a life-changing experience. So I think a lot of us experience that and know it from their experience. What are continuations and how they contribute to scalability?
Yes, so what you mentioned is that in some frameworks you turn on one flag and it basically gives you a lot of performance benefits, mainly scalability benefits. So it does not apply universally, so not all applications will benefit from it equally or that highly. If your application is I/O bound, so it is doing a lot of, let's say, networking, network calls, or maybe a lot of database transactions where your application has to wait for something, then all that waiting would be avoided. So your CPUs would not be blocked during those times. And these are the applications typically where virtual threads would provide huge performance benefits.
And this is why all the I/O frameworks are so benefit so greatly
from virtual threads and Project Loom in general.
Yep.
But if your application is CPU bound, compute heavy, then you would still need to think about whether you want to switch to virtual threads or not, because there you would not get that performance boost or scalability boost as much as you would like.
Okay, so where continuations come in?
Yeah, so continuations are used to implement virtual threads. So a continuation is, you can think of continuation as a representation of the current state of the program. So your program, let's say it's executing at any point in time, you want to take continuation that will give you the current state of the program as an object. And then you can pass that object in your program anywhere, and then you can continue from there. Right? And continuations are very useful for implementing virtual threads or green threads, but they are also a general purpose utility, so they could be utilized somewhere else. That we also discuss in the talk, where I also show an example of implementing a data structure called generator using continuations. So they are also general purpose utility and could be used at many other places, but virtual threads is also, continuations are a natural choice to implement virtual threads. And
it sounds familiar to me and reminds me of reactive programming.
Yeah.
The passing of state. This is something that it sounds familiar.
Right.
So how those two are related?
Related, yeah. Virtual threads really provide a power to increase scalability of your applications, right? And reactive applications also have similar benefits. So there is some kind of overlap that they address to. And if reactive programming is useful in many different models, in many different applications. If you are using reactive programming model for getting more CPU out of your CPU, then that may not be the right choice, because then you could simply switch to virtual threads and you could gain that benefit without changing your programming model. So these are the areas where you would need to think whether you want to still stay with reactive programming or you want to benefit from Project Loom and virtual threads. But In general, what I would think about reactive programming is that if your model really has that natural, domain where you have entities interacting with each other and passing on messages, and the nature of your domain is reactive, then you would use reactive programming model. But
That
otherwise, you
makes
would.
sense. All right.
Yeah,
And then continuations where they step into this model.
Yes. So continuations are actually used in JDK to implement virtual threads. So basically, it's a building block that you would use to implement a virtual thread. And that's also part of the talk where we actually implement a simple version of virtual thread using continuation. So there is continuation API in Java. We use that and we create a simple virtual thread in the talk itself. And we also see that it provides scalability benefits. So
Very nice. Very nice. Well, that was fascinating. I learned a lot. I hope our audience as well. We can learn more by watching your talk.
it's on Friday, 9:30. Yeah.
If you're here, just come to the talk. If not, wait for the published videos. It's what we like. It's hardcore. It's great demos. It's it's explaining complicated topics in a nice way. Well, thank you very much.
Thanks, Arul. Thanks, Farooq, for having me. Thank you.
And for you folks, stay tuned for more episodes of the Bill Erosion Lab at DevOps Belgium 2020.